And 38 years of experience in concept building and problems. Today's challenge is problem related to wave optics. Let us look at this problem. So it is a problem related to Young's double slit experiment. If a thin transparent mica sheet of refractive index 1.5 and thickness T is placed in front of the upper slit. So here it is. What is actually uh, what happens when transparent mica sheet is introduced in the path of the light? Before that, you should know conceptually. I can give a formula and I can explain, but concept I am explaining. Optical length of medium. What does it mean? Suppose light travels 8 meters in water whose refractive index is what is its optical length means in the same time in sense light takes t seconds to travel 8 meters. In the same time, distance traveled by a light in air or vacuum is how much distance it traveled means mu d 4 by 3 into 8, 32 by 3, 10.67 centimeters. That means if light travels 8 meters in water is same as is optically equivalent to it traveled 10.67 centimeters in air. So what is the idea behind it? In medium, it travels d distance. So time taken to travel this distance in medium, speed by, sorry, distance by speed. Speed what? Velocity of light in medium. In the same time, what is the distance traveled by a light in air? So distance is equal to velocity of light in air in the same time. That is c into d by cm. C by cm is nothing but refractive index. So that means so light travels more distance in air in the same time than medium. How much excess distance means mu minus 1 into d. So this is the basic idea behind solving this problem. Right. What he given YDSC experiment obviously two slits are there. So light ray travels from the source and it reaches two slits. According to Huygens principle, each slit acts as a secondary source of coherent light waves, emitting secondary waves in all directions. So here, suppose one of the direction light travels, it reaches central point P, and from source S2, it travels S2P. Here, S1P is equal to S2P geometrically as well as optically because both are travel in air. So optical, here path difference will be 0. If path difference is n lambda, so we get a bright fringe here. Now what he did here is a transparent mica sheet of refractive index is placed of thickness T. So what will happen if once, because light has to cross medium, its speed decreases in the medium. Suppose light in t seconds, light from source S2 reaches P, right? In the same time, when mica sheet is introduced, geometrically, it will not reach, it gets delayed. Geometrically, S1L is less than S2P. But optically, so here, suppose when light ray after a certain time from S1 also reaches P, optically S1P will be greater than S2P. Geometrically, they are equal. Geometrically, these two are equal. So when path difference is not 0, then you don't get a central bright fringe. In fact, here central bright fringe shifts. So here, when in the path you introduce a mica sheet, it travels optically S1Q. Geometrically, S1Q is less than S2Q, but optically there is a possibility that S1Q will be S2Q. That means bright fringe shifted to some point. That what he given is bright fringe shifted, uh, that central bright fringe shift to fifth bright fringe. That means that path difference is this, which is equal to 5 lambda. Right? Path difference is what? N lambda. N here is fifth bright fringe. He given refractive index 1.5, 1.5 minus 1 into T. So anything else he given? He is asking answer in terms of lambda. T will be 5 lambda by 0.5, which is 10 lambda. So whenever in the path of light, transparent sheet is introduced, right, of some refractive index, light get delayed. But when both reach the same point, the distance traveled by a light through the uh, obstruction, that is any mica sheet, that distance will be more than this. Right? How much more means originally T is there, now mu T. Difference will be light travels extra distance, right, in the path of obstruction. Right. And here two coherent light sources. Coherent light sources means sources having same frequency and constant phase difference. This is also important. Even same frequency for constant phase difference is not there. They are not coherent. Their amplitudes can be different, right? So one wave equation may be like this: A1 sine omega t. Other one wave equation omega t plus phi at x equal to 0. So now what he is asking, ratio of maximum record intensity and minimum when waves interfere. So here is a source. Light is traveling through the slits. So it travel in all directions. When two waves met at some point, at this point, intensity of intensity of light, right, depends upon phase difference. At different point, different intensity will be there. That resultant intensity, it depends upon phase difference. As you know this formula, it depends on phase difference. I max you get when cos phi is 1, that is root I1 plus root I2 whole square. I minimum you get when phase difference is phi, that is minus 1, which you get I1 minus root I2 whole square. The question here is maximum by minimum intensity. I maximum by I minimum intensity is proportional to square of the amplitude. A1 plus A2 by A1 minus A2 whole square. A1 plus A2 will be here intensity he gave 9 is to 1, amplitude will be 3 is to 1. 3 plus 1 whole square by that is 16 by 4, you get 4 is to. These two generally they are these questions they are asking frequently, right? Better to know uh, instead of formula. If you learn with concept, it will be helpful to solve some other problems.